The following sequence has the property that the sequence of numerators is arithmetic and the sequence of denominators is geometric. So this means that the general term is Tn is equal to, the numerator is a plus n minus 1 times d, and the denominator is ar to the power of n minus 1. For us to find the common difference in the numerator, we subtract the preceding terms. So T2 minus T1 should be equal to T3 minus T2. T2 is minus 1 minus our first term 2, and T3 is minus 4, our second term is minus 1. Minus 1 minus 2 is minus 3, minus 4 plus 1 is also minus 3. So our common difference is minus 3. So to find the numerator of our fourth term, which is going to add minus 3 to minus 4, and this gives us minus 7. That is the numerator. For the denominator, to find the common ratio, we divide T2 by T1, which should also be the same as T3 divided by T2. We test this. T2 is 5, T1 is 1, T3 is 25, T2 is 5. If you divide this, you see that it's equal to 5. So our common ratio is 5. So to get the denominator for the fourth term, we multiply 25 by 5, which gives us 125. The second part of the question, we're supposed to determine a formula for the nth term. We already know that for the numerator, we have a common difference of minus 3, and our first term, which is a, is equal to 2. Then for the denominator, our common ratio r is equal to 5. Our first term is 1. We say the general term for this numerator being arithmetic would be a plus n minus 1 times d dividing ar to the power of n minus 1 because it is geometric. We substitute with the information that we have. My numerator will be 2 plus n minus 1 times minus 3, and my denominator will be 1 times 5 to the power of n minus 1. I simplify this. This will be equal to 2 minus 3n plus 3 divided by 5 to the power of n minus 1. We'll simplify this. This will be equal to 5 minus 3n divided by 5 to the power of n minus 1. So that is our general formula for our term Tn. The third part of the question, we're supposed to determine the 500th term of the sequence. We already know that the general formula that we got in part 2 is 5 minus 3n divided by 5 to the power of n minus 1. So we need to find T500. In other words, it means n is equal to 500. We substitute 5 minus 3 times 500 divided by 5 to the power of 500 minus 1. We simplify this. This will be equal to minus 1495 divided by 5 to the power of 499. This is the 500th term of our sequence. The fourth part, which will be the first term of the sequence to have a numerator which is less than minus 59. Our numerator is 5 minus 3n. This should be less than minus 59. We solve this. It means minus 3n will be less than minus 64. When we divide an inequality by negative, the sign changes. So if we divide throughout by minus 3, this becomes n is greater than minus 64 over minus 3. So n should be greater than 21.333 recurring, which means the term at n is equal to 22 would be that first term in the sequence to have a numerator less than negative 59.